In this second part of section 2.3, we're going to look at a concept called average rate of change, and we know that most commonly as slope. Okay, we're looking at slope, but this time we're looking at slope in terms of function form. Okay, so if we think about what slope actually means, remember we had that formula y2 minus y1 over x2 minus x1. So looking at this here, we're looking for the change in the y values, y2 minus y1. And here, if we think of A and B as being our A being from point 1 and B being from point 2, this is still our y values, f of x at point 2 minus f of a, and that's from point 1. So this is still y2 minus y1. Okay, this is point 2 x value minus 0.1 x value. So it's just the same concept that we've been working on with slope, just written a little bit differently. So if we look at this in terms of a function, we have the function f of x equals 3x squared. So I'm looking at this from the interval of 1 to 3. So I'm starting with x equals 1 to x equals 3. So this is like saying I have an x1 and a x2 value. And when I plug in 1 for x, I have f of 1 equals 1 squared is 1 times 3 is 3. If I plug in 3 into my function, I have f of 3 equals 3 squared is 9 times 3 is 27. So these values in the parentheses, f of x, these are our x values, and these are the y values associated with them. So if I look at my formula up here, I have f of my second point is 3, minus f of my first point, x value is 1, over my second point is 3 minus 1. Okay, so these are our y values after I plug in 3 and 1 into the function, and these are our x values, 3 and 1. So if I just do the calculations, I have f of 3, we figured that out as to be 27, minus f of 1, which is 3, and then 3 minus 1 is 2. So this is actually 24 over 2, which is 12. So now I want to extend my my x values. Here I went from 1 to 3. This one I'm going to 1 to 5. So I'm still going to find the y values associated with 1 and 5. So according to this formula, my second value is 5. So I'm going to find f of 5 minus f of 1 over 5 minus 1. If I plug in 5 into my function, I have 5 squared is 25 times 3 is 75. I already found f of 1, and that is 3, over 5 minus 1 is 4. So this is 72 over 4, which is 18. Now I'm going from 1 to 7. So I'm going to have f of 7 minus f of 7 minus f of 1 over 7 minus 1. And f of 7, if I plug 7 in here, I get 7 squared is 49. 49 times 3, I did that calculation, is 147. And f of 1 is still 3. And then I have 7 minus 1 is 6. 147 minus 3 is 144. Over 6 is 24. All right, so if I think a little bit about what this actually means, and I'm just going to kind of draw this up above here. If I were to graph 3x squared, I would get a parabola. I'm just going to kind of make a parabola here. And if this is 1, if I'm looking at my first interval, I'm going 1 to 3. Here's my slope between those 2 points. If I'm looking at 5, here's 5 on the parabola, the y value of 5. So now if I connect those 2 points, there's the line that goes between them. And if I look at 7 and put a y value up here, between 1 and 7, here is my line between those 2 points. And if you look what's happening, here's our first line that had a slope of 12. Here's our second line that had a slope of 18. And here's our third line that had a slope of 24. So as our interval is increasing, okay, as my interval is getting bigger, my slopes are increasing. So that's kind of what this is showing. In this second part, we have this function, and it's 3x squared minus 2x plus 3. And we want to find in part A the average rate of change, and I abbreviate that as ARC, from x equals -2 to x equals 1. All right, so this is our x1 value, this is our x2 value. So I need to find my y values. So if I plug in my x value of 1, so I'm going to find f of 1, or in this case it's the g function. So I'm going to find g of 1, and if I plug in 1, I'm going to get 1 squared is 1 times 3 is 3, and then minus 2 times 1, 1 times 2 is 2, so that's minus 2, and then I have plus 3. And if I simplify this, I get 3 minus 2 is 1 plus 3 is 4. If I plug in g of 2, or from my second point, I'm going to have -2. So I'm going to plug in -2 for x into the function. So I have -2 squared is 4, times 3 is 12. Then I have -2 times -2 is positive 4. And then I have a plus 3 at the end. And simplifying this, I have 12 plus 4 is 16, plus 3 is 19. All right, so these are my x1, x2 values, and these are my y1 and y2 values. So for my average rate of change, if I just kind of plug this in, I'm going to have f of 1 minus f of -2 over 1 minus -2. And this is, we know these values now, f of, and again, it's g. I'm forgetting here. So g of 1 is 4 minus g of 2 is 19. And 1 minus -2 is 3. 4 minus 19 is -15, divided by 3 is -5. So the average rate of change in this function from -2 to 1 is -5. Okay, and we're going to keep that thought here for just a second. And part B asks us to find an equation of the secant line. Okay, the secant line. If we remember, secant line is the line connecting 2 points in a function. So if I'm writing an equation of a line, I need some information. I need a slope and a y-intercept, or I need a slope and another point. But if we think about our x and y values, I do have 2 points here. My 2 points, my first point is the x value of -2 and the y value of 19. So -2 and 19 is a point on my function. I have point 2 is the x value of 1 and the y value of 4. Now I only need 1 point and the slope to write the equation of a line. Okay, if I think of y minus y1 equals the slope times x minus x1, I need a slope and a point. Well, I found my slope up here at -5, and I can use either one of these points to plug in for x1 and y1. I like the numbers 1 and 4 better than calculating with 19, so I'm going to choose x1 and y1 to be 1 and 4. And I'm just going to plug them in the equation of the line. So I have y minus y1, which is 4, equals the slope, which is -5, times x minus x1, which is 1. So I have y minus 4 equals, I'm just simplifying this to be -5x. -5 times -1 is +5. And if I add 4 to both sides, y equals -5x plus 9. So this would be the equation of the secant line that's going through those 2 points. Okay, so that kind of sums up this quick lesson, working with the average rate of change, calculating slope, which is what the average rate of change is, and we can use that information to write an equation of a line, and they call that the secant line going through 2 points on a function, and that's what we did here.